folks, let's take a look at this next example. So in this example, I've got this rational expression. At minimum, I actually would need to simplify what's on the left side here so I could move forward with the problem. But on top of it, this term, 5 over 3x, I need to subtract it because I need a 0 over here. So I got a whole bunch of shenanigans I'm going to have to do. So I'm going to move this 5 minus 3x over so I can have a 0 on this side of the inequality. Then I'm going to go find the least common denominator and add and subtract those fractions. So my first step would be to subtract 5 over 3x from all sides, right? And again, that would give me a 0 on this side by design. Now I'm going to write that over here just so I have a little bit more space as I start to write this problem out. So we're looking at 1/3 minus 2 over x squared minus 5 over 3x. That's going to be less than 0, okay? Now what I'm going to do, I'm going to find this LCD, all right, as I always do, and I'm going to multiply every term in this on this left side of the inequality. I'm going to multiply it by its own unique version of 1 so I can get common denominators. So if I look between 3x squared and 3x, if I want to get that LCD, all right, I need the 3 because I can see the number of 3 is 3 in there. And then if I look, I have an x here and an x squared here, and I always need to grab the higher power to make my LCD. So my LCD is going to be 3x squared. So let's start to see what we're missing from each of these respective denominators to our common denominator. So I'm going to take 1/3, okay? I'm going to subtract, and I'm going to put some space in between it, right? I'm going to subtract 2 over x squared, and I'm going to put some space. I'm going to have minus 5 over 3x, and that's ultimately going to be less than 0. But let's mess with this. So if I look at 1/3, right, this first fraction, 1/3 here, if I look at my denominator on this fraction to the common denominator, to the least common denominator, I see a 3 here, I see a 3x squared here. I'm missing x squared. So I'm going to multiply this particular fraction by x squared over x squared. And x squared in ratio to x squared is just 1. So I'm not actually changing the problem because 1/3 multiplied by 1 is still 1/3. It's just this is a very special version of 1. All right, let's look at our second fraction, right? 2 over x squared. If I compare the denominator for this fraction, x squared, to the least common denominator of 3x squared, right? X squared to 3x squared, what am I missing? A 3. So I'm going to multiply this fraction by 3 over 3. Right, again, 3 over 3 is 1, so I'm not actually changing 2 over x squared. I'm only multiplying it by 1, so I'm keeping it the same. It's just going to look a little different, and it's going to allow me to add and subtract fractions. And then if I look at 3x to 3x squared, right, this denominator to the LCD, I'm missing x. So I'm going to multiply this by x over x. All right, so if we start to simplify this, right, when you have, I'm going to do PEMDAS. I'm going to do this product, and this product, right? We're going to do the multiplication first, then I'll take care of all the addition, subtraction. So I'm going to multiply numerators, multiply denominators. I've got 1 times x squared, 3 times x squared. All right, so you can see it's x squared over 3x squared. That's this first fraction. I'm going to subtract out. All right, 2 times 3 is 6. X squared times 3, also 3x squared. I have a common denominator. That's by design. I want this to happen. If I look at this third fraction now, I got 5 over x and then 3x squared. Again, by design, all less than 0. Okay, let me just put a little kind of separation bar there. So now that I have common denominators, I can just collect the numerators together. So ultimately what this is going to turn into is I'm going to keep 3x squared, and then on the numerator I have x squared minus 6 minus 5x, and that's ultimately going to be less than 0. Now I'm going to clean this up because I tend to write my polynomials in descending order of their power. So what I mean is I'm going to write x squared, then minus 5x, then minus 6. All right, so I'm actually going to just kind of scooch it this way so we can see my end game, not even my end game, just my mid game inequality. All right, so this original inequality has now been manipulated so it looks like this. But the good thing, or the better thing between my original problem and what I have now, I have a 0 on one side of the inequality, and then I can go factor this, right? So I can factor this because I'm going to set both numerator and denominator to 0. So ultimately I'm going to have to factor x squared minus 5x minus 6, make a sign pattern, and then see what kind of pops out after that. So let me scooch this up just so we can move forward with the problem. So I'm going to remember that I have x squared minus 5x minus 6 over 3x squared less than 0. So this is my new rational inequality that I want to start to evaluate. So I'm going to set numerator and denominator to 0, right? So I'm going to set x squared minus 5x minus 6 to 0, and then I'm also going to set 3x squared to 0. Here I can factor. I think we're going to go with x minus 6x plus 1. And however you factor, go ahead and do it. If it's the AC method, if it's guess and check, if it's the little, I always see these little like boxes, like these little triangle, like almost like crosshairs. I see that all the time. Here I'm going to divide both sides by 3, right? I'll get x squared is 0 because 0 over anything is 0. Or I should say any fraction where the numerator is 0 means the entire fraction is 0. Here I use the zero product property. X minus 6 is 0 or x plus 1 is 0. So I'm looking at x equaling 6 here, negative 1 here. When I take the square root of both sides, right, if I square root this, I'm going to get x is equal to plus or minus 0. But plus or minus 0 is just 0. So I actually have 3 interesting values in this, right? I have 0, I have negative 1, and I have positive 6. So I'm actually going to put all 3 of those on my sign pattern, but let me scooch this up and just keep in mind, I'll try and keep it in view that I want to look for where things are strictly less than 0. So let me move this up just slightly so we have some room to make a sign pattern and then get our final answer. So as I start to write this out, okay, I'm going to give myself some room. All right. So I've got my smushed xy axis. X's are on the bottom, and I'm going to put x, well, I'll put the factored form here. I'm going to put, what was it, x minus 6, x plus 1 over 3x squared here. All right, and can we see all of that? Looks like it. So I put this rational expression here, but it's the factored form in the numerator. So instead of writing x squared minus 5x minus 6, I'm showing it with the factors. And the 3 points of interest, or the 3 x values, were negative 1, 0, and 6. So let's see what each of these values do to this fraction. If I plug negative 1, if x is negative 1, and I plug it into this fraction, the numerator will 0 out. And 0 over anything is going to be 0. So when you have a 0 in your numerator, your fraction is 0. All right. When I plug 0, right, x is 0 into this fraction, it zeroes out the denominator. Anytime you have a fraction where the denominator is 0, that fraction does not exist. And then similarly, when x is 6, if I plug that into my fraction, my numerator again zeroes out. 0 over anything as a fraction is still 0. Okay? And it's at this point, you can pick some test points, right? So you could, maybe plug 7 in over here, maybe 1, maybe negative 1/2, negative 4. You could plug all those test points in and collect your like pluses, minuses, however they go, right? We'll pretty much have like plus, minus, that's pretty common. Maybe minus, plus. Maybe something doesn't alternate signs, but you can always test them with test points. I would say it takes a little bit longer, but it's not too terrible. I'm going to do it the faster way. I'm going to use the Lie coefficient, and then I'm going to talk about when things change signs and when they don't change, or when they alternate signs and when they don't. So once you have more experience with this, you start to see the pattern in these sign patterns. So if I look at the lead terms, and I'm going to go back, and I think we can see it. I have an x squared in the numerator and a 3x squared in the denominator. If I look at my lead numerator term and my lead denominator term, I know there was like a minus 5x minus 6 up top, but when it comes to these sign patterns, it's always the lead term that determines it. This is essentially a 1 on the numerator. So this is basically 1/3. And as a fraction, that is positive. And since that's positive, our rightmost interval will have a plus over it. So if you look at the lead terms, right, in terms of positive or negative, if you look at those coefficients, it always determines the sign of the rightmost interval. And then it's a matter of, do things have even or odd exponents in terms of whether they alternate or not. So if you have an odd power, all right, if it's an odd power, you're going to alternate signs. And I'll show you what I mean, right? If you have an even power on your factor, you're not going to alternate signs. Alternate, there we go. Okay. So what I mean by that is I move, now this time, this is the one time I'll go right to left. Most of the time in math, we're going left to right on an x-axis. This is the only time, well, not maybe the only time, but this is a pretty common time I actually go this way. And it's just, like I said, the shortcut method for getting these signs. So I'm starting with a lead positive, then I hit 6. 6 comes from this factor of x minus 6. Now the exponent on that was a 1. That is an odd number. All right, so I'm going to alternate signs around 6. So when I say alternate, I'm going to change from plus to minus. Okay. The next x coordinate I run across is 0. 0 comes from x squared. And you can see this one has an even power. So I'm not going to alternate signs. So if there was a minus here, I'm going to keep it. All right, I'm not going to alternate. The next x value of interest that I come across is negative 1. Negative 1 comes from the factor of x plus 1. All right, that has an odd power. So since it's odd, I'm going to alternate signs. So I'm going to go from minus to plus. Oops, that's not a good looking plus sign. And again, you could have picked 4 test points, and that might work better for you. You might be more comfortable with that. That will always work. So if you're more comfortable with that, by all means, use that method. Now, can we see it? I think we can see it. I ultimately want to see where this thing is less than 0, right? So if I want strictly less than 0, I just want to look for negative symbols. I see one here, and I see one here. All right, so I see 2 intervals there, and I need to write them up as 2 intervals. I can't just cover 0 because 0 doesn't exist. So I need to ultimately remove that from my answer key. So I'm going to scooch this up just a wee bit. Oh, let me lift that paper so it'll move up. So my answer here is going to be all of the x values between negative 1 and 0, and then 0 to 6. All right, and I'm going to put parentheses on these ends because it was strictly less than 0. And I have to remove x equals 0 because that makes my fraction undefined, and I can't include 0 in the answer. So what I mean by that is, if you had told me negative 1 to 6, this is incorrect because this version that's an arrow. This interval includes 0, which does not exist, right? So that's why we have to remove it from our answer. All right, so it might look like negative 1 all the way to 6, but because 0 is a D&E, we need to remove that possibility from our answer. All right, thanks so much. Bye.